Hi, linear algebra student. This video is for chapter 2.1 matrix operation. So in chapter 1, we use matrix to describe a systems of equation or a vector equation, meaning that matrices are actually vertical vectors, columns. But actually matrix can be just an array of number, and you can treat it as an objects with that had operations. So you can treat it as if it is a number and perform mathematics arithmetic operation on it. So in this chapter, we'll just treat matrix not associated with vectors or equation, but as an object. So this is what we talk about in the past. We say we define a matrix as vertical columns of vectors. Each of these vectors we have n vectors, and each one is a m entry vectors, and so you would have m times n matrix. M is the number of rows. We say that is row, and then we have n columns. Technically, we can say the dimension of a vector is m times n if there is n rows. M rows, I should say M rows, and there's n columns. And then we actually will give labels to each, or variable names to each of the entries in the column. So in the past, we say this is the first vectors, but and actually we didn't name it. Now we're gonna give it a name. So because this is the first row, so we give the entry Aij. Each one is called Aij. I is the row number, so you can see that all the names of A here is one something. Okay, A11, A12, A1n. And then for here, for vertical, so because they would be in different rows, so the number, the variable name for the first part would be different. So this would be AI1, and this is AIJ, and this is AIM. So you can say, if you had to write them, this is A11, this is A12, because it's still the first row, okay? And then all the way A1n. This is the second row. So you'll be started with A21, but it's the first column. So the second digit is, the digit represent the column position. So A22, like that, and this is A2n. And then all the way, because we have M entry, so the last one will be M1. And then M2, the last one will be AMN. So this is called the naming convention of a matrix. Diagonal entries are one where the subscript ij are the same, right? A11, A1, A22, A33, A. If it is a M times N matrix, so this is may not be an M times N matrix, but if you have A11, A12, those are called diagonal entries. Diagonal matrix are where number of row and number of columns are the same, and we say they're N times N matrix, where this is not diagonal entry. This is identity and matrix. So if it is a identity matrix, then you would have 1 and then all 0. So except for the diagonal entries, 1. So this is 2, 2, 1. All the other 0. 3, 3 is 1. And n is 1. All the others are 0. So if it's a 2 by 2, then you have I2. If it's 3 by 3, then it's I3. So I2 means 1, 1, 0, 0, 2 by 2. I3 means 1, 1, 1, and then all these others 0. Okay. So I am. Okay, so matrix is in entities that we can deal with. So the first thing, just like vectors, to deal with is multiply a scalar and also add and subtract them. So if I have a matrix A, 405, negative 130, I can add them. I can multiply with a scalar R. So if you add matrices, you will add corresponding entries, right? And but because you're adding corresponding entries, they must have the same size. Same size, that means same row and same column to add. And if you multiply by a scalar, you multiply each entry by the scalar. For example, you can add A and B together. You add 4 and 1 become 5. 0 plus 1 become 1. 5 plus 1 becomes 6. Negative 1 plus 3 is 2, etc. If you multiply B by 2, you multiply each of the entry by 2. So 1, 1, 1 become 2, 2, 2. 3, 5, 7 becomes 6, 10, 14. Okay. And you can actually um, subtract two matrices together after you multiply a scalar. So you multiply the entry to B first, and then you subtract. When you subtract corresponding one. It's pretty straightforward. But matrix multiplication is a little more difficult because what happened is we can define matrix. Actually, in the past, we have talked about how to do matrix multiplication with a vector x1 to xn, right? So x1 to xn are the weights in the past, and then you would do a1, a2, an to say that that is equal to x1 times a1, the whole entry. So these are weights, right? Time a column vector, a2, an times an. But if I have another if I have a times not just x1, xn, but multiple weights here, what can I do? So we can treat this as different weights. The first is the b1 weights, so we do a times b1. And then the second is another weight. The third is another weights. So what happened is you would actually do A being each column matrix, and then use these weights to multiply them. So it'll be 4 times, so this would mean 4 times 2 and 1, right? So, and then 3, 2 is another weight, also times 2 and 1, and 3 and negative 5, right? So let's look at A times B1. So this would be 4 being the weights times 2 and 1, and 1 being the weights times 3 and 5. You add them. Right? So it's 4, 2, 1 plus 1, 3, negative 5. And you can see that it is 8 plus 3, that is 11. And then it will be 4 minus 5 is negative 1. And then A times the second B. This is another way, so it will be 3 times the first column, negative 2 times the second column. So that would equal to this. And then the answer would be combine these three things together, it becomes the answer of AB. So this is one way of looking at matrix multiplication. Another way of looking multiplication is using the row column rule for computing AB. Row column rule means you would multiply, when you multiply together, you multiply the whole row of A and the whole row of column to get one entries. For example, A, B, I would write 2, 3, 1, negative 5, and then write B, 4, 1, 3, negative 2, 6, 3. Now I'm going to do the multiplication. See how I do. First, I look at the whole row, 2, 3, and 4, 1. So for one entry, I do 2 times 4, because this whole row, okay? And then 4 times 1, plus 2 times 4, and plus 3 times 1. 3 times 1. So that's just one entry. And then I do the second one, which is still the first row, but the second column. So I would say 2 times 3. But then this is the second number. I multiply by this one and add them together, minus 3 times 6. And then the last column would multiply with the first row, 2 times 6 plus 3 times 3. And so that would be the answer for the whole first row only. What about the second row of the answer? The second row of the answer, I would use the second row of A and the first and then the columns of B. So 1 times 4 minus 5 times 1. So this is the more popular way of calculating matrix multiplication. So another one, 1 times 3 minus, oh well, actually minus 5, 5 times negative 2. And then still row column 1 times 6 minus 3 times 5. Now we're going to do the add together. So this would be 11. 2 times 3 is 6. 6 minus 18 is negative 12. 2 times 6 is 12. 12 plus 9 is 21. Then 1 times 4 is 4. 4 minus 5 is negative 1. 1 times 3 is 3. 3 plus 10, 13. And then 1 times 6 is 6. 6 minus 15 is negative 9. So you would have this answer. So remember, when you are to generate this number, you use the first row and the first column. First row and the first column. How do you use it? You get 2 times 5 plus 3 times 1. When you are to generate negative 12, you use the first row because what? Because it's the first row, right? But the second column, so 2 times 3 plus 3 times negative 2, and 2 times 3, 2 times 3 plus 3 times negative 2. Oh, I think I get a mistake here. It's 3 times negative 2. So this one, I think this would be 0, right? Let's check answer. And then the last one, this times this will be 2 times 6 plus 3 times 3. So this one is right. 12 plus 9. So that's 21. Then the second one we'll do 2 this times this. The second row times the first column. 1 times 4 minus 5 times 1. And then the second row multiply the second column. 1 times 3 plus 10. 13. And then the second row times this will be 6 minus 15. Yeah, so this is the wrong one that I just did. So row times column method. So because of that, the size of the column must be equal to column number of A must equal to the row number of B, right? So the column number, this has how many column? It has 2 column. And how many row do I have? 1, 2, 3, 3 rows. So you cannot do this, right? Because if you multiply horizontal times vertical, it doesn't work. What about B times A? So I have 2 columns, but two rows, so this one works. Okay. What about A and C? When I multiply, I need to have the number of columns and the number of rows is the same, and so this would work because this is 2 by 2. So what happens is if you have m times n for A, the B has to have n times P. So this 2 has to match. The column of A has to equal to the row of B. Okay, if this is so one way to quickly check is to check if the columns of A is equal to the rows of the second one. What about CA? C has 3 columns. A has only 2 rows, so that doesn't work. What about C and D? C had 3 columns and has 3 rows, so this would work. What about DC? D have 3 columns and it has only 2 rows. That doesn't work. Right? So sometimes you have one work, but the other doesn't. So like AB does not work, but BA works. Can I multiply AD? A has two columns.